Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze concrete column with rectangular section for its compressive test. We will start by double clicking on static structural module. We'll first go to engineering data and double click. Here I'll create the material concrete M30. I'll give the first property of density, which is 2300 kg per meter cube. Then I'll click on concrete M30 again and I'll go to isotropic elasticity and double click. I'll first give the value of Young's modulus in megapascal, which is 25. Poisson's ratio is 0.18. Also, I'll give the value of compressive yield strength in megapascal, which is 30. Then I'll go to project and update project. Next, I'll go to geometry and right click. New design modular geometry. Units, millimeter, XY plane, look at. I'll go to sketching and choose rectangle. I'll go to dimensions and give these two dimensions, one horizontal and one vertical. Horizontal dimension is 100 mm and the vertical one is 50 mm. Next, I'll go to modeling. I'll choose extrude. I'll select the sketch 1 which is created. Apply. Then I'll give the depth, that is the length of the column, as 3 meter, which is 3000 mm, and I'll generate. So here you can see this is a rectangular column. So once this is done, we'll close this. Then I'll go to model and double click. I'll first go to geometry and click on the solid. I'll change the material to concrete M30. Next, I'll go to mesh and generate it. I'm not changing the default size. You can change the size as per your requirement. For example, if this is too big, you can change this to, I'll first change the units to meter. And this value is 0.01. I can generate. You can see this is a fine mesh now. Previously it was a coarse mesh. Now I'll go to static structural, right click, insert fixed support at this end. So I'll select face here such that it is easy to select. Apply. On the other end, I'm going to apply force. So I'll select this, right click, insert force. This will be of compressive type, so you just have to check the direction. This side is direction Z. So I'll just change this vector to component. Along the Z axis, I'll apply 8 kilonewton load. You can see here this is of compressive type. So now we'll just make this column vertical. You can see this is compressive type of load on the column. Then I'll go to solution, right click, insert deformation total. I also want to see the deformation directional along the Z axis. So I'll change the orientation to Z axis. I'll right click again, insert strain equivalent. Also I'll insert the stress equivalent. So we'll go to solution and solve. We'll first go to total deformation. We go to edges and click on no wireframe such that you can see the column very clearly. The meshes will not be seen. I'll go to contour and select smooth contour such that the colors blend into each other. So now we can animate and check the deformation. You can see the highest deformation is 0.19 meter and the minimum is 0 at the fixed end. Next, we'll see the directional deformation. Now you can see the results in mm if you want. So you just have to change the units. So along the z-axis, it is 191.95 mm, which means it is 19 centimeter. So it is obvious that it is quite high value, which means you need to change this value of force. 8000 is a large load for this column and you will have to change it. You can also see the equivalent strain. It is 0.089, which is maximum. Minimum is 0.0457. If you check the stress, it is 2.248 megapascal. Now this indicates that the stress is low because you have given the yield compressive stress as 30 megapascal and this is just 2.248 megapascal. So it is quite low, which means this 8000 load is not going to be creating too much of stress or strain. But if you see the directional deformation at this zone where the load is being applied directly, there the effect is quite high, but below the effect is going to be low. The reason is it's a long column. So here obviously there will be a effect of this load. So this is indicated in the stress value and the strain value as well. So that's how you can analyze. Now if you want, you can increase the value of force and you can see the stress is going to increase, the strain will also increase and the deformation is going to increase further. But that will be highest in this top zone. In this lowermost portion, you will still see very less value of deformation. So this is the analysis of a solid rectangular column. In the previous session, we have seen a solid circular column. So you can just see the difference between the two. With this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.